Okay, so part 2, number 1, I got for the requirements an SRS and then X bars normally distributed.
Yep.
Okay.
Okay, number 2, I got 41.8 and 51.6.
All right, yep, that's what I got.
Number 3, I got 39.9 and 53.5.
Yep.
Yeah. Okay, number 4, I got 41.277 to 50.722.
For A, is that right?
Yeah. And then for B, I got 39.44. Did you guys get the same thing?
For A, I got different. I got 41.8 and 51.6.
Okay.
For A and B, I got the same numbers that I got in numbers 2 and 3.
Okay.
Yeah. I feel that.
All right.
Um,
Did you use SPSS both times for it? Or
I
like
used SPSS on A and B of 4.
Okay.
Yeah.
I mean, yeah, realistically it should have been the same, so probably just rounded or something weird, but I'm sure that's fine.
Okay. Number 5 then. How does the margin of error of the 95% confidence interval compare to the 99% interval? And it's a 95% interval has a smaller margin of error.
Okay.
Yeah.
Yep.
That's pretty much it. Number 6A, the null hypothesis is that it is 47 years of age, and an alternative is in 6B, I got negative 0.118. So what I did 46.73 minus 47, and then divide by the standard deviation 8.83 divided by the square root of 15. So I get negative 0.118. Degree of freedom in C is 14 because you just take the sample size minus 1, which is 14. And then the shaded area, whatever. So basically, I use that normal applet. I don't know how to show you guys how it would look like.
Yeah, that's fine.
So, and then E, the value is 0.907. And then I put down it's a failure to reject the null hypothesis.
Yep.
Yep.
And then 8 is that we don't have sufficient evidence to say that the mean is at the mean age of the customers start buying a home or at that average. Yeah, that.
Yeah.
Yep.
Okay.
Right.
Okay, number 3. In previous lessons, we have assumed that the population standard deviation sigma was known. In this lesson, we are making a different assumption about sigma. What has changed? Sigma is unknown.
Yep. Okay. For the null hypothesis is population mean equals 8, and the alternative hypothesis is population mean is greater than 8, and the population standard deviation sigma is not known. Becca collects a sample of size n equals 9, and computes sample mean equals 11, and s equals 6. So is sigma known? No.
All right.
Exactly with the value of t. What's that noise? Is it me?
I have no idea what that is.
Wait, what?
We're hearing some weird noise.
Yeah, I hear something too.
I don't know if that's me or not.
I don't know.
I don't know.
I don't think it's me.
I have no idea.
I got 7.
5?
Yeah.
I got 1.5.
Hold on one again. So you go 11 divided by.
How are we just using 8 for the U?
Yeah.
Okay.
Okay. So I did 11 minus 8 divided by s, which is 6, divided by square root of 9.
Mm-hmm.
That's 7 for some reason. Am I doing this wrong?
Yeah, I got 7 too.
Divided by 6, divided by square root of 9.
Oh, but when I do like, it depends on where you put the parentheses, because
Yeah.
minus 8 is 3. Yeah, so if you just do like 3 over, parentheses 6 over square root of 9, then you get 1.5.
Okay. So we'll go with 1.5.
Yeah.
Okay.
Okay. Use the following values, which were pulled from the data file from BodyTemp. Copy and paste them into the software you are assigned to use. Using the null hypothesis, HU equals a 98.6, and alternative is it's less than 98.6 and level of significance 0.5. What is X bar? Okay.
Has everyone got it into the software?
Almost, but okay. One. Okay, for the mean, did you guys get 98.22?
Yep.
Okay.
Sorry, Jeff. Mine won't let me. You guys can go ahead. It's not allowing me.
Okay.
You said that the sample is at the 6982.22.
Mm-hmm.
This is start with a load on me. Not sure.
Hold on. Okay. All right, so number 7 was 0.922.
I think so. I was confused about that, how to find S.
I think it should just be the standard deviation.
Okay. Yeah, it's the only thing that makes
Yeah.
sense.
Yeah. It's true. Okay.
And
What are we comparing it to?
for the T-score, I got negative 1.843.
Yeah, that's what I have too.
Wait, when I did it on here, on the SPSS, I got 476.407.
Did you use the null hypothesis to compare it to?
No, I did not.
Do you know how to do that? When you have the list and then you go to analyze, compare, means, and then one sample t-test, you select the list, and then underneath the test variables box, there's a test value box, and you type in 98.6. And then the p-value, I got 0.081.
Yep.
Okay.
Okay, that's what you said. So when I go into analyze, compare.
Compare means, and then one sample t-test, and then you move the variable, the list, and then underneath that box it says test value, and you type in a number.
Oh, so you put 8 down?
Well, you put 98.6.
Okay, yeah, sorry. I was like,
Yeah.
negative
Yeah, I didn't get that the first time I tried
Yeah.
it.
That was tricky.
Yeah.
negative. You guys get negative 0.1. I'm sorry, negative 1.843.
Yep.
Is that what you guys got? Did you find 9 yet? The p-value?
Yeah, it's 0.081.
0.081.
Yeah, it's the sig two-tailed.
Okay. And then our level of significance is 0.05. So
I think that we failed to reject.
Failed to reject. Yeah.
Yep. Okay. Now we do this again, I think.
Yeah, looks like it.
Okay.
hey, so I'm a little bit confused on how do you know which number to put in the test value? Oh, I get it. Figure it out by hand. No, just my normal app. What did you guys get for 11?
I got 0.995.
Yep, I got the same. And for 12, failed to reject.
Yep. Okay, 13, You decide to try another alternative hypothesis. This time you use less than 40 and keep the same level of significance. Does the p-value increase or decrease? I'm not sure on that one. What do you guys think?
Yeah, I'm not sure how we test that one.
Yeah. Let's see.
I'll use that though. If it's less than 40.
I think the p-value would decrease because, well, if you have if you had the probability applet open and you have selected both sides of 40, then it would be a certain amount. Then it would be 0.995, and if you only had, less than 30 instead of less than or greater than 40, I think it would decrease. That's the only thing I can.
Yeah, no, that makes sense.
Okay. All right, and then what decision do you make? I think it would just be fail to reject the null hypothesis. Still.
Yeah.
The 15, compare the level or interval for question 11 and the confident interval for question 13. Which one is wider?
I think that they're the same, but I'm not completely sure on that.
Yesterday, I remember on the homework.
Let's see.
I don't know.
Yeah, because I'm not sure how to compute it when it's less than or not equal to. And
Yeah,
that's why I think it would just be the same, because I don't think that there's really a difference of the confidence interval.
Okay. I don't know.
But yeah.
Okay. Should we submit?
Sure. Oh, got a couple wrong.
Why was the t-score wrong? Did you get the extra for 9?
Yeah, mine was wrong too.
Oh, sorry. Oh, the p-value is wrong. Sorry, not the t-score. Wait, what? Okay. Alyssa, did you already uploaded the group meeting for 10?
Not yet, but I will after this,
Okay.
and then you can go and look at it.
Let me get my pattern to see what we need to get.
All right. So what time works for you guys next week to meet? Does the same time work again?
Look at my calendar.
Next Saturday. So I won't be able to meet. I can meet on Friday. Or I can meet Saturday, but it has to be later, like 10 or 11.
Okay.
Because I get off work at 7, but I don't usually really get off at 7. I usually get off.
Yeah.
Or if you guys want, if it doesn't work out with your guys' schedule, I can just come back and watch the video too if that.
What is your schedule like, Alyssa?
Trying to see. I think it's changed. I put it down on the phone. I know I work next Saturday. I just can't remember what time.
Okay. Well, you can just like text me later this week when you find out, and
Yeah.
then I can figure out a good time for everyone to meet.
Okay. Yeah, that'll work.
Okay. Sounds good. Then we'll see you later.
All right.